So now we're doing linear functions. So before we had functions, now all the functions are going to be aligned. So you did ones that were absolute value. You did ones that were parabolas. Now they'll all be straight lines. 5.1, the first part is identifying. Identifying linear functions. That whole word linear, that really, the part we're focusing on, has all kinds of words in it, like line and ear.
Oh!
And
fun. Near. Fun. Near. Fun.
Near.
Fun. Jesus.
In. If you're a pirate. Arr. So the point we're trying to get at is, so the linear function is going to be a straight line. Okay, linear function. And the function part, when something's a function, you know each x. Anyone want to finish it off?
T.
Has only one y. So each x has only one y value. And that question showed up on your last quiz with that mapping diagram, I think they called it. All right. So my first part I want to do in here, though, is Roman numeral 1. And I'm going to say, is the graph a linear function? So is the graph a linear function? So is the graph a linear function? For me, I'm just going to go, instead of like writing out the words like function, not a function, linear, not linear, I'm just going to go through and put like an L underneath it if it's linear, put an F underneath it if it's a function. Ready? So the first one, that there, is that linear?
Yes. Yes.
Yes, it's linear. It's a straight line. Is it a function?
Yes.
Yep, so it's L and F. It's going to be both. If we were to take, instead of a line there, if we were to do a parabola, is that going to be linear?
No.
Nope, so no L there because it's not a straight line. Is it a function?
Yes.
Yes, because if you pick one x value, one x is only going to have one y, so it's a function. If I were to do one like this here, is it linear?
No.
Yes. So it's aiming for a horizontal line. So if we have a perfectly horizontal line, is it linear? Is it going to be a function?
No. Yes.
Yep. Because for each x value, for this x value it only has one y. For this x it only has one y. A good rule of thumb is you could do what they call a vertical line test. If you could take and do a vertical line, do you agree this orange line here, all the x values on that orange line are the same? Do you agree all the x values are the same on the orange line?
Yeah.
Yep. So if it's a function, any vertical line will only touch it once. And they call it the vertical line test. So this one's linear and it's a function. If I were to take two more, if I do one that's aiming for a vertical line. So if I do a vertical line, it's not a function, but it is linear. Nice. So it's a straight line, so it's linear, but it's not a function because when you have this x value, this distance side to side, you have multiple y values. The very last one, kind of a square root function, kind of a parabola turned on its side. Is it linear? No. Is it a function? No, because if you do a vertical line through it, the vertical line hits it twice. So for whatever this x value is for this orange line, it has two different heights, has two different y values. So this one here then is neither. Yeah, if you have a horizontal line like this one over here, it's going to be linear and a function. Vertical lines, though, are just going to be linear because it's straight for the linear, but that one x value has an infinite number of y values. Then Roman numeral 2, Are the points linear? So if you have something you're trying to figure out if the points are linear, basically linear, a straight line. So linear. If it's straight, it has to have a constant slope. So a straight line will have a constant slope, or the same rise per run if you wanted to. For that, you could say the same rise over run. So if you have a graph, if you have a graph, just look at it, is it a straight line? But you could try to count out, it's like, okay, I can see this point here. How much does it go up? How much does it go over to see another point? If you were to have a data table, that gets a little bit tougher. So if I have like an XY with a point 1, 3, and then 2, 6, and then 3, 9. What you could look at here is you could look at, for a certain change in X, do you have the same change in Y? For a certain run, change in X, do you have the same change in your Y values? So for this, if I do like from 1 to 2, that's a plus 1. From here to here, I have 3 to 6, that's a plus 3. So its slope there is 3. That when X goes up by 1, the Y value goes up by 3. So it'd be like a rise of 3 for a run of 1. You could do that same thing here. Then it goes up 1 for my X's. It goes up 3 for my Y. So far that one's going to be a straight line. Those 3 points would all be in a straight line, yes? Which would be another way to do it, would be to take and actually put the points on a graph. And is it a straight line? Is it not a straight line? What messes some people up is they'll get something like this here, add a 5 and a 15. And is it still a straight line if I do a 5 and a 15? Because now my X's are going up by 2, my Y's are going up by 6. Well, if I were to do a rise of 6, my Y's change by 6 when my X's change by 2. Do you agree 6 over 2 is the same as 3 over 1? They're both equal to 3. So you could look at something like that. Should I give an example of one that's not? Or I guess I could just say something like, if we had maybe take and change this 9, get rid of these even. I don't think I'd try to write this if I were you. I'd leave it the way you had it. But if I take and make this instead 8. Now if I were to do that, this one here goes up by 2. So I don't have that same change in Y for a certain change in X, so it's not going to be in a straight line. If I graphed these, I'd have my first 2 points are going to be in a line. It's like 1, 3, 2, 6. But now my next one is going to be like a 3, 8. It's not continuing that straight upward trend. Yeah, Emma? So is it still a function? Yes, it would be. Because we don't know what's in between those, we can only look at the 3 points. But you could take and say, well, for this X value, an X value of 1, it only has that 1 Y value. For this X value, there's only 1 Y value. Where it wouldn't be a function would be if I had like that same X value of 2, so I also had like the 0.29 or something like that. Then it wouldn't be a function. Good question. In Roman numeral 3, does the equation give a linear function? So does I'm going to do an EQN for equation. Does the equation give a linear function? So does the equation give a linear function? This, you could go and try to memorize some stuff, but as you do more work, you're just going to get better at seeing kind of what's what. Here are the 2 main equations for a line. And this one we're going to do a little bit later on this chapter a bunch, but I'd write it as capital A times a lowercase x plus capital B times a lowercase y equals capital C. That we're going to talk about that soon as that standard form for a line. And what they mean by that is x and y are typically variables, right? So A, B, and C are going to be numbers. So you could, if you wanted to, write A, comma, B, comma, C equals numbers. Or by that, you could have one like, actually I should move my example back a little bit. So for example,
Do you know who put letters in math? Like, why?
In other words, A here is the number 5, B is the number 3, C is the number 15. Good?
Why does it equal 15? Because it's times.
It could be anything. It could be equals 15. 15 is kind of like the height. So it could be 15. I just picked that because the numbers would work out nicely if you wanted me to graph it. But it could be a 20 instead if you wanted to. And the 5 and the 3 have to do with the angle or the slope of the line. And the 20 has to do with how high is the line above or below the x-axis. That's kind of where the numbers come from. That's officially called like standard form for a line. It's the standard form equation for a line. So one thing that you could do is you could look for the ax plus by equals c. Do you have a graph that, or do you have an equation that fits that? The more common one is y equals mx plus b. On your last test that you took, we had a data table and said write an equation for a line. The equation that you came up with fit this pattern, where in this time we have m and b, maybe I do our numbers. And a little bit later on you'll figure out that m is going to be the slope of the line, b also then is kind of like the 20, it has to do with the height. So an example of that could be something like y equals 2x minus 7, or y equals 2x plus 7, something like that. And we'll do a lot more of that equation. That's the nice equation. Here's kind of the rules of thumb. So if you're trying to figure out if something's an equation, something that'll help is if you know these two forms. If you know these two forms, that's going to help you see if something's a line. Because a lot of them will be in one of those two forms, like, yup, it's one of the ones I know, it's a line. If it's not in one of those, you could try to take and change it to one of those two forms, especially if you change it to y equals mx plus b, do that. If it fits it, you're good. Or anytime you have a y equals, punch it into your calculator and then graph it. Does it look straight? Is it not straight? If you don't want to do it one of those ways, here's kind of me trying to come up with what rules could you say something has to fit for it to be a line. And the first one, I just have 2 or 3 rules, depending on how you break it up. One is all variables to the first power. So all variables to the first power. So in the last chapter we had y equals x squared. As soon as you see the x squared, you know it's not a line. Something different. The second one is you can't have a variable times a variable. And in some respects you could that's really covers rule number 1. Because when we have y equals x squared is just x times x, right? But this also covers if you have y times x equals 4. If you have y times x equals 4, that's going to be a hyperbola. It's not a line. The other option is that you can't have, so no number divided by a variable. So if you have y equals 5 over x, or even really x divided by y equals 5, neither one of those are going to be a line.